Fencing is a very quick-paced sport. It is popular in countries such as England, France, Italy, and Russia. In physics, velocity is a vector quantity that shows the speed and direction an object is going at. The equation to calculate velocity is v equals d over t, where d equals distance and t means time. An example of velocity in fencing is to show how fast the foil is moving forward when it's thrusted. The foil is one of the 3 tools used in fencing. It is flexible and made out of metal. To calculate its velocity, use the distance the tip of the foil traveled, for instance 0.9 meters, and divide it by the time it took to travel that far, 0.3 seconds. The equation should look like 0.9 meters over 0.3 seconds, which equals 3 meters per second for the velocity. Fun fact: fencing is such a quick sport that it is said that the tip of a foil moves as quickly as the bullet of a gun does.
Next, it's acceleration. Acceleration is an object's velocity changing, usually at a constant rate. The equation for acceleration is a equals velocity final minus velocity initial over time final minus time initial. An example of this is when a foil is flicked and bounced around. The foil moves quickly at first and eventually comes to a stop. When the foil comes to a stop, its velocity is 0, so the final velocity used in our equation is 0. This will result in the acceleration being negative. If the velocity of the foil oscillates in at first is 5 meters per second and the foil goes from 5 meters per second to 0 meters per second in 1 second, then our equation would look like 0 minus 5 over 1, which equals negative 5 millimeters per second per second.
Newton's first law of motion. This law is referred to as inertia, which is the natural tendency of an object to remain at rest or at motion unless an outside force interferes. For example, the tip of a foil in fencing would oscillate forever if the friction from the air did not stop it.
Force. Force is the energy that is exerted from an object. Force is measured in newtons. Newtons means kilogram times meters per second per second. Mass. Mass is the amount of matter an object has. Do not confuse mass with weight. They are different. Mass is typically measured in kilograms.
Newton's second law of motion is used to calculate force and weight. This law says that when you multiply mass and acceleration, you get the force. There are 2 formulas for this. Formula 1 is weight equals mass times gravity. Formula 2 is force equals mass times the acceleration. An example would be that if a fencing saber's mass is 1.2 kilograms and you multiply it by the acceleration of gravity, which is 10 meters per second, you find that the weight of the saber is 12 newtons.
Newton's third law is when you push on something and it pushes back the exact same amount. An example of this is when you push on a wall. Instead of you falling through the wall, you stay put. The wall pushes back on you just as much as you push back on it.
Another great sport is wrestling. It has great examples of projectile motion. Projectile motion is a form of motion where an object is thrown into the air and makes a curved path. When dealing with projectile motions, it's important to know that the vertical velocity and the horizontal velocity have no effect on each other. An example is when a wrestler throws someone into the air during a match. When thrown, the person makes a curved path in the air. Throughout the curved path, gravity is pushing the same on the person and is unaffected by the horizontal velocity of 5 meters per second. On the curved path, the vertical velocity is negative on the left side because it is going up and against gravity, which is why it also gets smaller as it goes up. At the peak of the curve, the velocity is 0 meters per second, and then it starts to descend. On the right side of the curved path, the velocity is positive because it's going with the gravity. The velocity is changing by 10 meters per second each second because of the acceleration from the gravity. There is no additional forces to accelerate the horizontal velocity. That is why it stays the same the entire time. Another example would be if two people were on a cliff. One person is dropped and the other is thrown. The thrown person is called a projectile. They have some horizontal velocity while the person being dropped has 0. Since once again, horizontal and vertical velocities are independent and don't affect each other, both people will land safely on the ground at the same time.